Okay. We look at yet another concept, which I could almost promise you would be one more that you need to just understand the questions and calculate and go for it. Okay, and go for it. We are still working on our differences, the difference between an ionic compound and a molecular compound. But now we are not looking at the formula or looking at the structure, looking at the properties. No. Because we looked at the structure and we saw that for molecular compound, they have molecules that are discrete, which means that are separate. Then we saw for ionic compound, it is a lattice, which is a 3D arrangement of ions where you have a positive ion completely surrounded by negative ions, right? And you have a negative ion completely surrounded by positive ions. So it's like that. They have an arrangement like that. Then, we saw those other things. We saw the formulas where we said we have a molecular formula and a formula unit. Formula unit for ionic compounds, molecular formula for molecular compounds. Now we are at yet another difference between the two. Let me not say right now it's a difference. We are not just focusing on the difference now, but now we want to learn about a concept that is going to be very, very important for us, and it has to do with the mass. And it will help us when we are doing our mole calculations, etc., etc. So let's keep going. First of all, we are going to talk about 3 key masses, and then we'll see how they relate to the fourth one, which is very important. So we start with one which you might not see listed in your notes, but it's very important, and that is what we call the atomic mass. So we want to talk about the atomic mass and a unit made for it called the atomic mass unit, because it is what is going to link with the rest. It's going to be very important for us. So when we say we are talking about the atomic mass, everyone here knows that an atom is very small. You can't even go inside it. We've never seen a picture taken of an inside of an atom. If you see them say, if you go inside an atom, there's a nucleus, blah, 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 blah. These are things that were tested by experiments, not by a picture. So an atom is very small. It is so small. So you say to me, how do you know the inside? Well, we used experiments. Now, when we want to get a mass of such a small thing, how are we going to do that? How are we going to be able to see the mass of such a small thing? Well, to know the mass, when we are dealing with the atomic mass, we are saying it is the mass of a single atom, right? When we say we have the atomic mass, it's the mass of a single atom of an element. Now, this atomic mass here is the thing. We said it is the mass of a single atom. Such a small thing? Yes! The mass of one atom is the atomic mass. Now, because it is so small, for us to be able to work with it, we use a unit called the atomic mass unit. We use a unit called the atomic mass unit. This is the same principle we do in many of the things in life. When we are dealing with, for example, when you are dealing with small masses, when you are dealing with the mass of when we are dealing with the mass of whatever it is that we're dealing with, maybe the mass of a marble or something very small, we don't like to use kgs. Of course, kgs are our SI units. But if we're dealing with something very small, we use grams as mass, because kgs are for big things, right? So when we're dealing with something very small, we have to use grams. When we're measuring small quantities in the lab, we use grams, because to use kilograms, we would have them as very, very small things, and then that will make it very hard and complicated for us. So that's the same thing with mass, atomic mass. We don't want to use grams. Grams are too big. An atom is way smaller than 1 gram, the mass of one atom. It's way smaller. So we use a different unit called an atomic mass unit, which is a very special unit. As you see down the line, it was made by people after careful consideration. It's an amazing unit. This unit called an atomic mass unit. It is what we are going to use when we want to know the mass of one atom. If you take only one atom of something, you can check its mass and you can record its mass in U, which is atomic mass unit. This atomic mass unit here, we said it is defined when we're just talking about the definition, Because if you look around, you see them defining it professionally. They are defining it as 1/12 the mass of a carbon-12 atom. So one unit was made in a special way And here they said it is 1/12 the mass of a carbon atom. That is where we got 1 unit. In other words, we are just saying, when we say it's 1/12 the mass of a carbon atom, we are just trying to say that it is a tiny unit of mass. It's used for small things, and it is used to express atomic and molecular weights. So what is the atomic mass? It is the mass of one atom. What unit do we use? The U, the atomic mass unit. Why? Because it's a special unit that was made for small things, so that we can be able to work with them. Here is what one atomic mass unit is in grams. Look at how small it is. 1.66 times 10 to the negative 24. Times 10 to the negative 24. That is something very small. 0.000000000000000000000001. You keep going. Gram. Look at how small that is. That's ridiculous. That is so small. But yes, that is what your atomic mass unit represents in grams, because it's for small things. It's for small things, okay? So why do we use atomic mass unit? Because it simplifies the calculations for us. Instead of saying 0.00000000 times whatever, because we are keeping our mass in grams, we convert it to atomic mass units. When we want the mass of one atom, please use U, because an atom has such a small mass. To try and use grams, you're going to have an ugly value, very small value, which is going to be complex. So because of that, whenever we deal with our atomic mass units, we use U. And that is the mass you see on the periodic table. You see on the periodic table, you'll be having, let's say, carbon. Carbon is going to be 6 and 12. The atomic mass is 12, the bigger one, okay? And that'll be your atomic mass. Now, when and why do we use that such a mass? Because it simplifies calculations for us. Imagine having a mass of 12. That is very easy. But if it was 0.00000 for grams, that will be very difficult for us. Okay, because if we use grams, values would be way too small and very hard to work with. So for convenience, we use atomic mass units. Now, what is the atomic mass unit of hydrogen? H, if you go on the periodic table, is just 1.0076. Oxygen, you go to the bigger number on the periodic table, you see it as 15.999, which is just 16 atomic mass units, U. And that'll be atomic mass. Atomic mass in atomic mass units is there on the periodic table, and it's going to give you that. Now let's keep going on before we talk about more. Let's go down to the next, which is molecular mass. Okay, let's talk about this molecular mass. Now I'm going to pause the video here, and I'm going to record. We're going to start by talking about molecular mass in the next one. Bye for now.